Hello viewers, in today's class we are going to solve yet another important and very conceptual problem in definite integrals involving greatest integer function, right? So here we have once again an important problem, and here we have to solve this definite integral where the limits varies from 0 to log of 2. So here we have the natural log and tan inverse of greatest integer of e raised to x plus 1 divided by e raised to 3x, right? And here is the exponential number, right? So here we are dealing with the natural log. It means the base of the logarithm is e, which is the exponential number, right? So now let us solve this integral, and let us first call this integral as I, right? Now here what we will do, we'll first take t is equal to e raised to x plus 1, right? So here we have tan inverse of greatest integer of e raised to x plus 1, and so we'll put e raised to x plus 1 is equal to t, right? So now e raised to x is equal to t minus 1, and now from here, that is from this equation, we can have dt over dx, that is differentiating both sides with respect to x. We have e raised to x, right? So the derivative of e raised to x is e raised to x, and the derivative of 1 is 0, being a constant, right? And from equation 2, we have e raised to x is equal to t minus 1. So here we have t minus 1, so therefore dx is now equal to dt over t minus 1, right? Okay, so now let us change the limits accordingly, right? So here x varies from 0 to log of 2. So when x is 0, right? So when x is 0, the value of t can be calculated from equation 1. So here we'll have e raised to 0 plus 1. E raised to 0 is 1, so we have 1 plus 1, 2, right? And here when x is log of 2, then we have t is equal to e raised to log of 2 plus 1, right? And e raised to log of 2, which is the natural log, so this is 2 plus 1, that is 3, right? So here we have used the result, that is e raised to log of f is equal to f, right? So here we have e raised to log of 2, so for f we have 2, and that's why we have 2 plus 1, that is 3, right? So now this integral I, it becomes 2 to 3, right? So here when x is 0, t is 2. When x is log of 2, t is 3. So we have 2 to 3, and we have tan inverse of the greatest integer of t, right? For e raised to x plus 1 we have t, and in the denominator we have e raised to 3x, right? This can be written as e raised to x cube, and e raised to x is t minus 1, so we have t minus 1 cube, right? So here we have t minus 1 cube, and for dx we have dt over t minus 1, right? So now here we see that t varies from 2 to 3. It means t lies between 2 and 3, right? So when t lies between 2 and 3, then obviously by virtue of the definition of greatest integer function, the value of greatest integer of t is equal to 2, right? Because see, t lies between 2 and 3. So this is 2, this is 3. Now if we take for example, say t is equal to 2.4, right? So obviously the value of greatest integer of 2.4 is equal to 2. Similarly, if we take 2.1, then obviously 2.1 is greater than 2 but less than 3. So the value of greatest integer of 2.1 is 2, right? So now we have the value of greatest integer of t is equal to 2 when t lies between 2 and 3. So therefore this integral I, now it becomes 2 to 3, and we have tan inverse of 2, because for greatest integer of t we can write 2, right? Okay, so now we have t minus 1 raised to 4. So here we have power 1, so this is 3 plus 1 4, and here we have dt. Now tan inverse of 2 is a constant, so we can take it out. So we have tan inverse of 2 and the integral 2 to 3, and this t minus 1 raised to 4 can be written as t minus 1 raised to minus 4 dt, right? So now in order to solve this integral we can make use of the substitution method. So let us take u is equal to t minus 1, right? So du is equal to dt, right? And here t varies from 2 to 3. So when t is 2, u is 2 minus 1, that is 1, and when t is 3, then u is 3 minus 1, 2, right? So now I can be written as tan inverse of 2 and the integral from 1 to 2, right? So here we have 1, here we have 2, and for t minus 1 we have u raised to minus 4, and for dt we have du, right? And now here we can apply the formula for evaluating integrals of this type, that is x raised to n dx is x raised to n plus 1 over n plus 1, where n is not equal to minus 1, right? So now here we have tan inverse of 2, and here we have u raised to minus 4, minus 4 plus 1, that is minus 3, and here we have minus 3, and the limits of integration are from 1 to 2, right? Now we can take minus 3 outside, so we have minus 1 over 3 tan inverse of 2, and we have 1 over u cube, and the limits are from 1 to 2, right? So now we can substitute here the limits, and we have minus 1 over 3 tan inverse of 2, and here we have 1 over 2 cube minus 1 over 1 cube, right? So this is minus 1 over 3 tan inverse of 2, and this is 1 over 8 minus 1, and this is minus 1 over 3 tan inverse of 2. This is 1 minus 8, that is minus 7 over 8, right? And now minus and minus becomes plus when we multiply these two terms. So we have plus 7 over 24 tan inverse of 2, right? So viewers, the value of this integral is given by 7 over 24 tan inverse 2, right? So this is how we solve this important problem.